When a star 10 to 15 times more massive than the Sun reaches the end of its life, it explodes and collapses in on itself, forming a black hole. These stellar mass black holes are the types that most of us are familiar with, but it's very likely that there's another type of black hole that is much more common. Ones that formed in the first seconds after the Big Bang, before the first stars even began to form. And there's recent evidence that such a black hole could be found in our very solar system. Known physics break down inside black holes, making them amongst the most interesting objects in the universe. Despite this, the rules of their formation are actually extremely simple. Given any amount of space, if you cram enough mass into it, a black hole will form. It really is that simple. When a star explodes, lighter elements spew out and the resultant dense matter collapses in on itself and, if dense enough, a black hole forms. On the other extreme, if we smash two protons together fast enough, faster than even the current particle accelerators can achieve, it's thought that we could compress the two subatomic particles into such a small region of space that a micro black hole would form. Most primordial black holes are thought to be closer to these micro black holes. Right after the Big Bang banged, all of the mass in the universe was in an incredibly small region of space. With so much mass contained in so little space, small waves or ripples in this primordial soup would cause regions of this soup to contain more mass than the space can hold, forming a black hole. Thus, in these early moments of the universe, an incredible amount of these black holes could have been formed. Most of these early black holes would have been microscopic, just like the ones caused by two protons smashing together. These black holes would evaporate away as quickly as they formed. Larger ones, however, with a mass around 5 to 10 times the Earth and up, would still be around. The exact number is not yet known, but if one assumes that the elusive dark matter in the universe is simply matter contained in these primordial black holes, the predicted results eerily match the data we've recently discovered from Earth's gravity observatories. This might sound scary, especially the notion of one of these in our solar system. But these primordial black holes don't actually pose any more of an existential risk than other astronomical bodies. That's because unless you're right up at the event horizon, a black hole's gravity works like any other object with the same mass. If, for example, the Earth were to somehow be compressed down enough to form a black hole, it would still continue to orbit the Sun, and the Moon would still continue to orbit the now black hole Earth. Black holes have no extra gravity powers beyond the event horizon. Likewise, if one of these black holes happened to wander across the universe and meet our solar system, it'd be no different than a giant rogue planet crossing our path. It would not suck up everything we know, but rather it would likely get pulled into our Sun's gravity and settle into a stable orbit at the outskirts of the solar system. And there does seem to be evidence for such an object beyond Neptune and Pluto. People had theorized of an additional planet for over 100 years, but the idea really picked up steam in 2015 when two Caltech astronomers announced evidence that a giant planet far beyond Pluto is responsible for the unique orbits of several objects recently discovered in the Kuiper Belt. But such a large planet in the outskirts of our solar system poses a problem. How did it get flung so far out? There are some theories for how this may have happened from within our solar system. But one of the leading theories for this, Planet X, is that our solar system captured a rogue planet, a body that had escaped its original solar system and had been wandering around in the darkness. But, as pointed out in this 2019 paper, this captured object need not be a planet. It's just as likely that our solar system crossed paths with a primordial black hole. It might even be more likely to be a black hole. The mass of the proposed planet is 5 to 10 times Earth, exactly the range of what we think the most common primordial black holes are. And, despite searching, we haven't spotted this object yet. Although certainly not conclusive evidence of a primordial black hole within our solar system, it's definitely enough evidence to start a dedicated search for the occasional high-energy blasts we'd expect from such an object. Unwin and Schultz, the authors of the 2019 paper, describe how such a search could be accomplished. It's also enough evidence to start seriously thinking about what we'd do if a local black hole was discovered. It would likely be the most important discovery of our lifetimes. Our fastest space probes top off at 430,000 miles per hour. At a theorized average distance of 600 AU away, it would only take us 15 years to put a probe in orbit around it. Once there, we'd be able to directly study the theorized behavior around this relativistic object. Can the extreme magnetic conditions and plasma jets caused by the black hole's consumption of matter actually be used to extract energy as described in the Blandford-Zanuck process? Could we harness the strange energy properties described in the Penrose process to collect negative energy and use this to power things such as the galaxy-traveling Alcubierre drives? Some speculate that black holes are in fact traversable and lead to other faraway regions of space. Wormholes. Might we be able to send something through? Or, wilder yet, observe something coming out? These are just some of the known unknowns that we might be able to solve. Who knows what unknown unknowns might be waiting for us there? It's incredibly exciting that we might actually get some of these answers within my lifetime. But of course, this does remain speculative, for now. But once the signs of a primordial black hole in our solar system are discovered, the countdown to answers will begin. Such an incredible source of potential answers would almost certainly usher in a new space age. Maybe we get there sooner than we think. Until then, I'll be here, speculating and keeping tabs on this and other issues pertaining to the space around us and the life it may contain. Thanks for watching. Please like this video and be sure to subscribe to Rather Be Squidding for more.